I'm Casey, and today we're going to talk about naming ionic compounds. An ionic compound is made up of a metal and a nonmetal. Your metals are your cations, and your nonmetals are your anions. Cations have a positive charge, and anions have a negative charge. Your metals, whenever you're naming them, always keep their name, and on your nonmetals, you're going to drop the last syllable and add your "ide" ending. So NaCl, you're going to keep sodium like normal. And instead of chlorine, it's going to be chloride. And then on this one, you're going to keep silver. And instead of sulfur, it's going to be sulfide. And then whenever you're given the name, you're going to take the charges. So magnesium has a 2+ charge, and chlorine has a -1 charge. And then you're just going to flip them whenever you write the formula. So you're going to have NgCl2. And then on this one, oxide has a -2 charge, and aluminum has a +3 charge. So it's going to be Al2O3.
Hello, I'm Dakota, and I'm going to talk about transition metals and polyatomic ions. On transition metals, they have no definite charge because you use the S block and the D block, and that's where those metals are. You use Roman numerals to name them like this, or you use the low charge gets the O, which is us, and the high charge gets the ic, which is the I. And that would be like this if you're us. So we have Fe2O3, and we would name that iron 2 oxide or ferrous oxide. There's a few exceptions that do have a definite charge that are transition metals, and those exceptions are zinc and silver. Zinc is always +2, silver is always +1, and on those you don't use the Roman numerals, you just call it zinc oxide or silver oxide. On polyatomic ions, they are on the back on the right side. On this one we have lithium sulfate. So when you write that, you would write it lithium and then look on the chart on the back on the right, and SO4 is sulfate, and it just stays the same. And then on this we have calcium hydroxide. So you look back on the front, and calcium has a +2 charge, is Ca. And then on the back, on the same side, on the right, you look at hydroxide, and it's got OH with a -1. So because this has a -1, this has a +2, you switch these like that. So you would get OH, and on polyatomics you have to put them in parentheses always. And some more review would be MgNO3 2, which would be magnesium magnesium nitrate. Let's see.
And aren't parentheses just if you have more than one poly, not if you just have one, right?
Right. So if this was a Ca, or if you just had one in the 1A metals, then this would just be like NaOH. You wouldn't need the parentheses on it. And then down here we have copper, and because this has a -2 charge, this would be copper 2 sulfate. Or it could be cupric, because the low gets the O and the high gets the I, and because that has a 2, then it would get the I.